Alright, welcome back. Here we are. It's lesson unit 2-1, and you can see the whole lesson there. Still in chapter 1. It is now in lesson 4 there, called Powers and Exponents. May not be familiar with the word powers, but I'm sure you've heard of the word exponents before somewhere along the way. So, as we go through here, we'll start with, again, just as kind of a reminder of what's expected. Make sure you set aside some time here, maybe about 10 minutes or so. Limit your distractions occasionally to write something down, so if you see the pencil and paper and the guy with the chalk, please add those problems into your notebook for sure. And after every lesson, go ahead and give us a just one question. You can ask more if you'd like, but at least one well-considered question. Alright, so the icons here will help you. This guy here with binoculars, just watch. Don't worry about writing anything down, and then you're familiar with the other two already. Here is California Standard 2.0. We'll be here throughout much of this unit, and then we'll move on to Standard 10.0 pretty soon. Today we will learn to evaluate expressions containing exponents. So expressions are just standalone mathematical statements without any equal sign. There will be no equal sign. We'll just look at these expressions, and then we're going to see if we can evaluate them and simplify them and so on. Here's your vocabulary: a power, a base, and an exponent. Again, base and exponent I assume would be pretty familiar to you. Maybe the word power might be something new, but we'll take a look here. So a power is an expression written with an exponent and a base. So basically, if you have an exponent and a base, then we can call it written to a power. So for example, this is a base of 3 that is written to what exponent? Well, the exponent there is 2. So this tells us how many times to multiply the base. So this is read as 3 to the second power, or 3 squared. In other words, the exponent tells you how many times to write down the base and multiply. So again, you don't have to write anything down here. You see the guy here with the binoculars. Go ahead and just watch. Nothing else to do here. So 4 to the second power means 4 times 4. Or 3 to the fourth power, you can see what this means here. 3 times 3 times 3 times 3. And 5 to the third power is 5 times 5 times 5, which we know is 125. The most common mistake with exponents is simply multiplying the base and the exponent. So for example, this 4 squared, some people might evaluate that down to 8. That would be incorrect. It's 4 times 4, which is of course 16. Alright, so your turn. Go ahead and listen for the answer here. I'm going to see if I can test your listening skills a little bit. What about this one? 3 to the second power. Hopefully you got 9 for that. 2 to the third power. How about 2 times 2 times 2 is 8. How about this one? 5 to the exponent there is 1. So 5 to the first power is just simply 5. 7 squared, or to the second power, is 49. 3 cubed, or 3 to the third power, 3 times 3 times 3 is 27. We saw that back in Unit 1. 2 to the fourth power, so that's 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth power is 16. 3 to the first, 3. 4 to the second power, 16. 5 to the second power would be 25. And how about this one? 1 to the fifth power. Your initial response might be the number 5, but remember, it's 1 times 1 times 1 times 1 times 1 is simply 1. Alright then, when a number is raised to the second power, we usually say it is squared. And that's because of the shape of the square here. You see S, if each side is labeled S, S times S, S to the second power, S squared. So consider then, if the area of a square is side squared, what do you think the area of a cube is? So if the area of a square is side squared, the area of a cube would be, taking a look here, squaring is side times side, and cubing would be side times side times side. So we're going to have an exponent of 3 here. Exponent of 2 on squaring, exponent of 3 on cubing. So when a number is raised to the third power, we usually say it is cubed. Okay, so in this case, just the generic letter S here, we have S to the third power, or S cubed. How about this? Write the power represented by the geometric model. So in this case, if each side is 5, then how would we write this as a simplified expression? We would simply say 5 cubed, or 5 to the third power. Take a look at this one. Fractions work much the same way. 2 to the fifth raised to the third power. We're just going to simply multiply 2 fifths times itself 3 times. And remember, way back from maybe 5th or 6th grade, it's 2 times 2 times 2 across the top, and 5 times 5 times 5 across the bottom. So we end up with 8 over 125. So with fractions, don't forget to multiply the top and the bottom. Alright, your turn here. Let's take a look and listen for the correct answer. Be sure to watch out for some negative signs here if they pop up. What about 1/3 to the third power? So if you were to write that out, 1/3 times 1/3 times 1/3, would you get 1/27? That's what you should have there. How about this one? 3/5 to the second power. In this case, I'm going to have 9/25. 9/25. 2/5 to the third power. How about 8/125? That's 3 2's on the top and 3 5's on the bottom. How about 2/9 squared? 2/9 squared, 4/81. How about 2/7 squared, or 2/7 to the second power, you might say? 4/49, that would work. And 1/4 to the third power. So this is going to be 1's across the top, 4's across the bottom. That'd be 1/64. All right, let's take a look at one more set here. What if we just have a simple integer like -5 squared? Well, remember, -5 squared, order of operations, we're going to take the exponents first. So it's going to be 5 squared is 25. So the correct answer here is -25. -2 to the third power, again, order of operations, exponents first, that's -8. With the negative sign out in front, of course, I'm sorry, I should say +8 with the negative sign out front. The answer is indeed -8 there. How about this one? Again, we're looking at parentheses around the -2. So this 3 applies to everything inside the parentheses. -2 times -2 times -2, again, would get you -8. 3 squared? What would that be? How about 9? 9 should be your right answer. What about 3 to the third power? 3 to the third power, 3 times 3 times 3, 27. -3 to the second power, that's -3 times -3, so that would be +9. And now you've got a -8 to the second power, but there's no parentheses here. So we're going to do the exponents first, which would be 64. And what's the opposite of 64? -64. 4 to the second power, 16. Pretty straightforward on that one. How about -2 to the fourth power? That's -2 times -2 is 4, times -2 is -8, times -2 again, back to +16. And one more thing, something kind of strange but true. Any number to the power of 0 is 1. Any number to the power of 0 is 1. So you see this pencil and paper, we want you to write that down. So here's some examples for you. If you look at any one of these, you're going to end up with the answer of 1. So any real number to the 0 power is 1, except for the number 0. That would be something we'll talk about a little bit later. So that's it. There's Unit 2-1. You can notice here, if you need some extra help, here's another video place to go. There's the thing you type in. There's your video examples. And don't forget to jot down a question you can ask the next day. All right then. We'll talk to you soon.